Hey everyone, it's David Bombal coming to you again from Oxford in the United Kingdom. Really happy to be talking to Hank Preston again. We spoke a lot last year and then work and holidays got in the way. So Hank, welcome. It's good to talk to you again.
Thanks, David. It's definitely good to be back into to the piece, and I'm looking forward to continuing our weekly, as often as possible calls. So.
Yeah, that'd be great. I mean, so that everyone's aware, Hank and I are going to try and have calls every week again, unless something happens. So hopefully we'll be producing a lot of content. So let us know what you would like me to ask Hank and, what topics we'd like to discuss or what topics you'd like us to discuss. Hank, as you know, is very knowledgeable about all things DevNet and development focused. So let me know what you want me to ask Hank during these calls. So Hank, you mentioned, I think, that we're going to talk about GitHub.
Yeah, as I was noodling on different ideas to go through, I thought that, let's spend a little bit of time talking about GitHub and Git and probably a little bit about how they relate, other tools like GitLab and Bitbucket and how they fit in, and why a network engineer might want to start using it for either just themselves or even as part of a team. So.
Yeah, that'd be great because I think Git and the whole GitHub thing it seems like very much a programmer's thing. Seems very unrelated, and I'm obviously just saying these things to stir the pot, but it seems very unrelated to to networking. So correct me.
Yeah, so I mean, Git at its fundamentals is a tool that was developed specifically to allow developers to better collaborate and work on code together. And so if we think about that from a networking perspective, you're like, well, why would a network engineer want to work on code? And I think we all recognize that at some point, different kinds of scripting and coding is coming into our world. But even outside of that, even though they were originally developed for developers and checking in code and C code and all the rest of that pieces, fundamentally all Git and GitHub are dealing with are files and changes to those files, tracking who made the changes, keeping track of proposed changes, making it really easy to experiment with an idea, flip back and forth depending on what works and what doesn't work. And network engineers, even if we take the coding out of it, what do we deal with? We deal with files. We deal with configuration templates. We deal with runbooks that we have to make changes. We deal with spreadsheets to track stuff that's out there. And so I think even if you're not doing a lot of coding yet, using Git and the tooling that's wrapped around Git to collaborate with folks can be valuable. And I'll give one example that seems to resonate with everybody. Is you have to admit when you've worked on a configuration template or some sort of a run book and you're proposing changes, you're working with the team that goes through. How do we do that typically today? Well, maybe we save the file someplace and we save it with an extension .v1. And then somebody makes a change to it and they change the extension to V2 and then V3. And then somebody jumps in and they were working off of V1. And so now we've got like V1A. And that headache that goes through, if you can get yourself comfortable with working with Git, you can take away a lot of that extra overhead that goes through because now all of that versioning is just built into the tool that's there. And so you don't have to try to do this artificial version control piece that's in there. You can just use an actual tool that's built and is really, really quite good at keeping track of versions. And if you ever need to go back in time, it's really simple. Well, I'll say it's simple once you understand the tool a bit. The really part will pull away. One of the other things that's nice about it is it keeps track of who makes changes to files. And so I know I've been in a place that said, well, who made this change? Who decided that we wanted to update the priority for spanning tree? And nobody wants to take the blame for it. Well, when you put everything into Git and source control, well, it keeps track of that for you. And and we'll see it when we get into some of the hands-on in the demo piece. There's a display I like to call the blame display. So you can see exactly who made every change to any file that's there. And so if you've got a question on it, you know who to go back to.
Yeah, I mean, it's quite funny, that example that you mentioned. I saw a while ago on Twitter, some lawyers or attorneys, whatever term you want to use, were talking about like the drafts of a contract. And it was getting more and more hilarious because it's like V1, V2, V3, no, V5 final, no, V5 really, really my final, really, 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 really my final, all that nonsense. So this sounds great.
It's insane. I mean, so related to the lawyer piece, I remember when Microsoft recently acquired, it's probably closed by now, right? They bought GitHub, and that was a big piece, and we can talk a bit about kind of how that factors into the use of GitHub in the future. But one of the posts that came out around that time was the actual lawyers for GitHub were talking about how they had moved away from the traditional lawyer mechanism of maintaining files and just store all of their drafts, all their legal docs have been stored as in source control using Git. And they'd fallen in love with the fact that all of these changes and things were just baked into it. And so, again, it doesn't have to be code. It really is just dealing with text files. And if you work with text files, you can take advantage of Git, even if you're not doing any coding at all.
Yeah, I think, if lawyers can use Git, then we as network engineers definitely can.
Without a doubt. And really, it's a complicated tool, but like anything that's out there, we could say that the algorithms and the functionality behind OSPF or EIGRP or BGP, right? All of the code that makes those work is pretty complicated. But in general, you don't have to know all of the details to use those protocols. And the same thing goes with Git. Under the hood, there's a whole series of complexity going on, but you don't need to know most of that to take advantage of the tool and get value out of it. So,
yeah, I think that's a very good point. I mean, it's always scary when you have to learn something new because it looks so complex. So I'm glad you said that.
Yeah, absolutely. Well, let's dive in and kind of see some of these pieces in action as we go through and walk through some of the fundamentals. And so I'm sharing my screen here. And so what I've got is on my left-hand side is I've got GitHub open, right? And this is my GitHub page, so github.com, and it's just /hpreston. And then over on the right is just a terminal window on my laptop. And so I'm working from my Mac workstation here, but like many of the tools today, Git functions on Mac, Windows, Linux, kind of anywhere you want to be. And the commands that we'll use to work with it are the same no matter what platform you're on. And so the Git commands, the Git functionality, it's going to be consistent if you're a Windows or Mac user as it goes in. And so
that's good to know.
Yeah. The first thing I want to talk a bit about is the difference between Git and GitHub. So over here in GitHub, I'm on a web page, and GitHub is a service. It's a service that's currently kind of owned and operated by Microsoft, but it's a cloud service. And what it offers is a place to store and work on and collaborate with Git repositories. And we can we'll start out by thinking of a repository loosely as just a folder that has everything to do with your project that's in it. And so let's say we had a repository that represented our network configurations, right? On our workstation, that's going to be a directory with a bunch of other subdirectories and folders. All of that combined is a repository. And so GitHub gives me a place to store those kind of offline in a collaborative fashion. And GitHub is collaborative coding, and it's kind of this social platform that goes in. And so you'll notice on my profile here, I've got my picture that's there. We can see the organizations I'm a member of. You can track your followers. And then the repositories that are there. You can see you can follow and follow. You can follow other people. You can track your followers. We'll talk about a bit stars and these other things that go there. But GitHub and all of these other services for storing repositories, it's this social platform that you can go through, and it's really about collaboration on your projects with other people that are there. Now GitHub, if you go to github.com, that's the public GitHub page, right? It's the place, it's completely free to set up an account. They have paid tiers, but even most recently, since the acquisition by Microsoft, they've made the free service from GitHub even more attractive because they enabled what's called private repositories. And so let's talk a bit about those. So if I go under my repositories list here, you'll see that I have different projects that are out there. And so my workshop code. So if you have ever attended one of my webinar workshops or a Cisco Live workshop or one of those, all of the code, the examples that I do, those are here in this repository called workshops. I talk a lot about Python and Python networking examples, and so I have a repository called Python networking and a series of other ones that are out there. Now, a repository can be public, which means anybody can see that repository. They can look at it. They can provide feedback. They can open issues or provide suggestions. They're wide open to the public internet. And then you can have repositories that are private. And I honestly don't know if I have any private for myself. Well, let me go look at another account I'm a member of where we can see the difference between private. So if I switch over from Cisco or github.com/hpreston, and now I went to Cisco DevNet, which is the Cisco DevNet kind of group organization of repositories. In here, right up at the top, actually, we can see that we've got one here that's labeled private. A private repository means that the only people that can see that repository are ones that have been explicitly given access to it, either through some sort of group membership or just saying, hey, you know what, I want to work with David on this project, but right now it's not ready for everybody to see it, and so just David and Hank can see it. But that makes it a private repository. It used to be with GitHub that you had to pay to get access to private repositories, and then at the beginning of this year, I don't remember exactly when, but it was a while ago, GitHub said, you know what, anybody can have private repositories. It used to be a paid feature. Now anybody can have those. And so if you're working on a project and you want to store it and have a place and maybe only work on it yourself or with a couple other people, you can create a new repository. So if I do that here on GitHub, I can say new repository and say, okay, I'm going to make it here. We'll say this is going to be example repo. I can give it a description. This is an example. And so, you know what, I'm going to make this one private. And so now you can say, it says you choose who can see and commit, or public, anybody can see it. Now, even with public repositories, only the approved people can make changes. So if I make a repository public, and most of mine are, anybody out there can see them, but only I and explicit people that I give permission to could actually change the code that's there. So it's kind of read versus write access that goes in. And then we see the other options, and we'll talk more about readmes and these other bits in a bit as it goes through on that side. All right, so I'm gonna pause for a second. Any questions so far, David? You're always good about keeping me honest and making sure I don't jump too far ahead too quick.
Yeah, well, one question was, in the past, I don't know if it's true, when you put code on GitHub, it became open source code, I think. So has that changed, or is it true? Or?
Yeah, that's a really good question. So the open source piece is an interesting one that goes out there. And so if you read through the GitHub terms of service, and I know everybody loves to read the terms of service and all of that user agreements that we agree to. But if you go through it, what GitHub says is that anything you put on GitHub is yours. And the license that's attached to it has to do with the license that you actually attach. And we can talk about that right now because it's on here. So if I were to create this new repository, we can see that I can add a license, but the default is no license. But if I drop the list down, GitHub has got like the common open source licenses or the common different licenses that are out there, and you can just grab one and you can attach it to the piece. And so if I wanted to open source this, I could pick one of these licenses. I'm typically a fan of the MIT license because it's a very permissive, it's a wide open license. So I can pick the MIT license and say, let's add this license to it. While we're in here, I'm going to go through and we'll hit these other ones. So I'm going to say initialize it with a README, which is just a text file that provides info about it. And it gives you a template that you can use. And then git ignores. I'm actually not going to add one now. We'll talk about that in a minute. And so I'll say create this repository. When I create this repository, I have explicitly put a license in. And you can see here, it's called just license file. And so if I click on the license file, GitHub put this in for me, and it says here's the text of the license. It's included in the repo. And then GitHub's pretty handy. It kind of gives you a details about it. Say, okay, well, what does the MIT license say? And it says, all right, the permissions are you could use this for commercial use if you wanted to. You're allowed to modify the code. You can redistribute it, which means you can take my code and give it to other people as part of your own project. Or you could use it for private use, right? If you just want to take this and just use it inside your own organization, I'm perfectly happy with that. Limitations in the license say liability, which means if you use my code and something goes horribly, horribly awry, it's not my fault. You can't sue me for it. And then there's no warranty. There's nothing that says Hank's going to fix something if you find an issue with it. So it's a very permissive license. You can do anything you want with it, but you also can't blame me should something go awry, or you can't count on me to fix something. It's a kind of a pretty typical one that goes through. Because I attached the MIT license, any code I put into this repository is open source under the MIT license. Now, if I didn't have a license file that's in here, what GitHub's terms of service say is that the code that you've posted is your code, it's Hank's code, and I have not explicitly said anybody can do anything with it. And so even though it's on GitHub and it's potentially a public repository, as far as the lawyers are concerned, I'm just putting it out there for people to look at. I'm not actually giving anybody access to do anything with it because I haven't said so. The way that the licensing works is that if you don't explicitly give somebody a license, they don't have a license that's there. Now that may or may not be what the person that posted it intended, right? A lot of people put stuff up there and they're perfectly happy for people to use it, but they didn't put a license in. But as far as GitHub's concerned and the terms of service and the way that their pieces go through, unless you put a license in it that makes it open source, it's not open source. It's yours, and you have the rights to put a license on it. I'm not a lawyer, right? So certainly remember that as you're listening to my dialogue. But that's how it's been explained to me by folks that are lawyers that I've had to talk to and kind of learn a bit about the open source world. So.
Yeah, I mean, that's great, Hank. I mean, it's I think your advice is good. Talk to a lawyer. But as a general premise, I think the concern for a lot of guys is they spend all this work creating code and then other guys can just reuse that. Now, I think on the flip side of that, open source has changed the world, and people like you have helped people around the world because you make your stuff freely available. So that's fantastic. I think the concern I would have as a network guy, if I was putting network device configs on GitHub, could it get compromised? You know, who has access to that? That's the concern about, say, proprietary stuff.
Yeah. So, I mean, and that's a really good point. So open source or not, if you put something on GitHub and it's in a public repository, whether you've licensed it open source or not doesn't mean that it's still there publicly and anybody can see it. And so that's one of the things that comes back whenever you're talking about these things is there's a bit of responsibility. Don't put anything up on GitHub, particularly in a public repo, that you are not okay with the wide open public finding and having Google index and have it be searched. If your organization, and we'll say this, right? If we're talking about network configurations for your company or your enterprise, if your organization has decided to use public GitHub, and that is the www.github.com on the public internet, for your actual internal use, and it's been decided by your organization that it's okay to post your network configs there, then great. But I would say probably not something you just want to do on your own for your actual enterprise configurations that are there. But there's alternatives. So GitHub, public GitHub, www.github.com, right, that's ran by a company. The company is GitHub, that's owned by Microsoft now. And they have a product called GitHub Enterprise. GitHub Enterprise lets you actually install the GitHub service, right? This entire collaborative thing where you can create and work with code, but rather than using it on the public internet, you can use it, you can install it in your own data center or in the cloud someplace and limit access to that repository or that application, just like you would any other application. And so many organizations, nearly every company I talk to these days, has some, what we'll call a private source control system. And so GitHub Enterprise could be a private version of GitHub inside of your own data center or inside of your own kind of four-walled garden. Data centers aren't always where everybody puts things these days. But if you put GitHub Enterprise privately, now you could put your source control or put your network configs there, and the only people that have access to it are the ones in your company. Now, GitHub Enterprise isn't the only option for that, right? So if I'm going to open up another tab here in the browser and go to gitlab.com. And so GitLab is kind of another kind of GitHub, right? It's a GitHub competitor that's out there. And so GitLab also has a public service where you can sign in and you can use it just like you would GitHub. But GitLab also provides what's called GitLab CE, or Community Edition, which is a completely open source version of GitLab that anybody can run anywhere. And so we actually run this inside of DevNet Sandbox. And so all of our internal functionality and pieces, right, we don't store those up on GitHub publicly, and we don't store them on GitLab publicly. We have a private version of GitLab where we store all of our internal source configurations, the build information, how we manage our own network and all those pieces. I wouldn't want those up on a public service, even in private repos, for a bunch of reasons. So we run those kind of in our own internal GitLab server. In addition to GitLab, there's also Bitbucket. Let me see if I can find that if I just Google Bitbucket. It's by Atlassian is another company. So GitHub's a company, GitLab's a company, Atlassian's a company, and Bitbucket is their kind of version of GitHub, their service that provides a place to put repositories and work together. All of these tools provide the same basic capabilities. It's a place to store your repositories. On those repositories, you can collaborate with other people, you can file issues, and I know we haven't talked about issues yet, but we will, and all that collaboration pieces. All of these tools, in addition to many, many others that are out there, they all use the actual open source part of Git, which is the actual Git application and the algorithms and the utilities that you work with locally on your own workstation, and we'll get to that in just a second. But they all use Git, G-I-T. It's a command line app. If I type git -- version, we can see I've got Git version 272 installed on my workstation. That application, Git, is open source. And I can use Git to talk to GitHub Public, GitHub Enterprise, GitLab, GitLab CE that I install, Bitbucket. Any of these services, all under the hood, are using the same open source program and algorithm and specifications, which is Git. All right, so that's the piece I wanted to hit first. Is there's two different parts to the puzzle. There's GitHub or GitLab, Bitbucket, right? The service, and then there's the application that we use to work with the service, which is Git, that's out there. And that tends to be the first bit that can confuse folks. So does that make sense? Any clarifying questions, David?
Yeah, I think that's really important, because I was going to ask you exactly that. Is Git, when people think about Git, they think GitHub, but it's actually a separate service. And the inventor of, or the original creator of Linux also created Git, if I remember correctly.
It is, yeah.
And the original yeah, go on. Sorry, Hank.
Oh, I was going to say, so if you go to git-scm.com, that's the webpage for that open source project that's Git. And as you mentioned, yep, it was originally developed by Linus Torvald, the originator of Linux, because when they were building Linux, they needed something that they could use, and so they came up with Git, and in good Linux fashion, it's fully open source.
Yeah, so I mean, that's great, Hank. I mean, the takeaway is we have Git, which is like an application, and then you have different, and I hate to use the terms, but like what you mentioned is you have like private cloud and public cloud versions of Git, if you like. So you could run GitHub locally on your sort of private cloud, and then you could run Git on, or you make use of the public cloud version of GitHub. Is that correct?
Yeah, and it's they're again private or public applications that you work with and places to store them. We'll probably, and in a lot of cases, where'd my mouse go? All right, so I've got Git running on my laptop, and then I've got the ability to work with all of these different potential services. And so we'll work with GitHub for a bit, because frankly, it is the most popular service, right? Public service for storing code, and you'll find code for tons of projects from tons of companies out there. And in fact, all of the DevNet sample code is stored up on GitHub, in addition to my personal sample code and examples, right? GitHub's where I put all those pieces. and as I already mentioned, I use GitLab internally right inside of Cisco. That's inside DevNet Sandbox. That's what we use. Cisco also has basically every application installed someplace inside of Cisco. So in any particular day as a Cisco employee, I probably use public GitHub. I use GitHub Enterprise inside of Cisco, and then I use GitLab because that's the one that we use inside of Sandbox as they go through. We also have Bitbucket by Atlassian inside of Cisco, right? So I think you'll find that in a lot of large organizations is that different teams and different purposes might use different tools that go through. But what is nice is that I don't need to have different laptops or different workstations or different VMs. My single laptop and my single version of Git on my laptop lets me work with all of these different services because it's that same underlying open source kind of bedrock that they're all built on that's there.
I just wanted to interject something, Hank. I think what's really nice about GitHub, firstly, it's the most popular that I've seen. But because there's this public version and people like you are posting so much there, someone who wants to learn this can very easily start getting into it by, running some kind of lab like a viral lab or Genus 3 lab or something, and then connecting to the public GitHub and kind of learning how it works before they make a recommendation at work. I don't know if you agree with that.
Oh, absolutely. I think that's a big part of the programmability initiative inside of networking is this open collaborative sharing thing that's out there. Particularly now, if you're getting into automation and programmability, there are tons of examples. And so odds are good you're not the first person to try something. And so you can find an example that's out there. But let's look at how we actually work with Git and some of the value that goes in. So that we've got some history and some pieces, I'm going to switch over to a repository that I've already got up there. And it's one that I think we've probably used in some of our other videos, David, which is my Preston Python networking repository. And so up here on GitHub, I can look at this repository. I can see that there's a license attached to it. I can see here there's the README. And so again, as I mentioned before, the README is intended for users of the repository or visitors to the repository to understand kind of what is this repository for. So I wrote this up that kind of gives some examples about how if you want to run and use the code that's here, just details that are necessary. So I can see I got instructions on how to set up and run. And so you run this git clone command, which I'll do in just a second. You change into the directory and then set up the Python virtual environment. So all of the details kind of necessary to use the code that's here are included inside of the repository. So let's go ahead and clone this down. And so git clone is the first command we're going to run. So this command that's here, so I'm just going to copy this and I'm going to paste this over in my terminal. And so what git clone does is git clone says, okay, I want to make a copy, a clone of a remote repository. And remote is a key word when you're working with Git. And remote just basically means someplace other than your local system, some other remote location where this repository is stored. So I'm going to clone a version of this remote repository that is up on github.com underneath the Preston kind of organization. And then the name of the repository is Python networking. And so you can see here it's cloning it into Python networking. And so it created a directory. So if I do ls-l, I now have this new directory called Python networking on my laptop. And so it cloned that copy down. So if I change into that directory, Python networking. And so now when I look in here, I can see that this directory, I'm just going to shrink the font down a bit so we don't get so much rolling of text. There we go. So now I can see that this folder's got a series of examples. And in fact, it's got exactly the same code that is up on GitHub is now local on my laptop. And I can work with it locally that's there. And so if I wanted to keep looking at the examples and say, let's say I wanted to set up and go through this, well, it's a Python example. So we need to create a Python virtual environment and go through. And so the commands here show me how to do that. I say, okay, on a Mac or Linux, I'm going to run this command. And so this will create a Python virtual environment. The next command is to source, which activates the virtual environment. And I think we've talked a bit about Python in the past, and I'm sure we will again. And then this pip install command installs all of the requirements for this repository inside of my virtual environment. And this dash R, oops, where is it? Dash R requirements.txt is saying read in all of the requirements that are listed inside of the file called requirements.txt. And we can see up here, there's a requirements.txt file in the repository. So everything about this project or these examples are kind of included in the repo. So when you clone that down, anybody could do this. You get everything necessary to take advantage of these pieces, including the requirements. So hopefully.
So in the most basic terms, Hank, this is like doing an FTP or just doing like a Windows copy of something in the cloud, and you've copied it locally in the most basic terms.
Yeah, so the git clone case statement, yes, it's just like I were to download it with FTP or the HTTP protocol. It's just using the git protocol to do it instead.
And then you're installing, based on the requirements file, a whole bunch of Python packages as required to run this example.
To run the examples, exactly. And so we'll let these go through, and then we'll while that's going, let's talk a bit about some of the other pieces that go through. So one of the things I talked about was with GitHub and using Git repositories is the versioning that's built in. So let's take a look at one of these examples that are out there. I'm going to try to find one that I've made some changes to. Let's see, so I'm going to go into the Device APIs folder, and I'm navigating this on GitHub, and we'll take a look at some of the CLI examples that are out there. And so I got 4 different CLI examples. These use NetMiko, and then I can take a look at any of these. So if I take a look at one of these examples, I can see, okay, so it's got 70 lines, and I go through, and this shows the code that's there, and so I can take a look at it online. But I can also say, you know what, let's look at the history of this file. And I'm actually curious to see how many changes. Okay, so the history of this file says that there were 2 different commits to this. And so a commit is a concept inside of Git that's basically a save point. And so when you're working on a file, you'll save that file using whatever Command S or Control S type of functionality that's there. And that, when you save the file like that, it's saved kind of in the active working place of that file. But when you want to lock in a version of that file and you say, okay, I feel good about that file. I think that I've got it the way I want it. I want to save, kind of lock in this current version of it. You do what's called a git commit. And every commit is logged as part of the repository. So you can see kind of what was committed at a particular point. And so I can look here. So back on July 18th, was my original commit to this repository, and it was called, I labeled this commit NetMiko examples. And so I can actually go in and I can look at this commit and see what was gone through. And so when I click on the commit, I can see all the changes to this file that were made. Now this was the initial commit, which means the whole file was brand new. And so all of these green plus marks say these entries were added to this file. And so it's the entire file. In fact, it's actually several files were added that were in here. And so it shows me the examples that are there. Now the initial commit will often look like this because it's the first version of the file. But if I go back and let's look at a different commit. Let's look at the commit that happened on September 6th. I labeled this one to use the always on sandbox, and I added a delete piece. And so if I was curious, well, what did Hank do during that piece? If I click on the commit, now up in GitHub, right, it shows me what changed. Well, I deleted this line, so the subtraction in the red says I deleted the import RE YAML line, and then I added 2 other lines. I added import RE and I added the import sys, so I just changed the imports for the file. I then subtracted this chunk of the file, like I got rid of this bit, and it looks like I replaced it with this bit of code that was here. And under the hood, if you look at it, I used to kind of pull in information from a YAML file like this, and in a different way, now I'm importing it differently. So I just made changes to the code that was there. Excuse me. I scroll down a little bit, I can see the other changes. I updated the with connect handler. So this is with NetMiko, how you connect to a network device. I just updated the connection bits a little bit to go through. And so every commit, you can always look at them and see kind of what change happened to each one of these as they went through. Does that make sense? Questions on that bit that's there?
Yeah, I think it's really interesting the way that you're explaining that. You cannot remember everything that you've done. And this is a great way to, like, what did I do 3 months or 6 months ago? This is a great way to actually see you know what you've done and keep track of all of it.
Exactly. Yeah. So in this, when I go back, I'm going to go back to the file itself. And what we can also see is that on this file, I'm the only contributor. Because this is just a repository I use kind of myself. Let me bring up another code example. I'm going to go to back to the Cisco DevNet. And then I'm going to grab something that's going to have a bit more interesting of examples that are out there. So we're going to look at the DevNet Express. So DevNet Express is it's an event, a program that DevNet hosts, SEs host, and lots of people work on these code examples. And so I'm looking at the code examples repo, and we'll go look at the we'll say the intro to NXOS. Trying to find, this one was updated 15 days ago. So this was a fairly recent update to the mission that was there. And so let me figure out which one it was. The WebEx Teams. I'm trying to find a file that's going to have more than one person updated. All right, this one will work. All right, so over here I found a file that this is part of an ACI lab. So this is the actual text that's behind one of the learning labs on ACI. And so we can see here on here there's been 2 contributors. And so I was one of the contributors. I actually wrote some of the original lab. And then we had one of our tech writers that have come in and made some changes. Now, if I was curious, kind of like what did D.I. Willis do, I can come here on the file and just click the blame button. And now when I look at it,
I like the name.
Yeah, it's a good name. It's a good name as it goes through. But when I look here, I can actually see line by line through the file, it attaches who did it and then which commit was it from. And so I can see initially 2 years ago, this line was created in the file, and then there was a blank line put in. And then 16 days ago, this line was changed. And so it looks like it was just some formatting one of our tech writers was working on. And so made some adjustments that were in there. But throughout the entire file, and this is one of the values that we get with using Git, is that this ability to track every commit, every person that did the commit, and the changes that happened to those. And so we can see how this file has updated over time. Still one file, but every part of that file has been stamped with kind of who did it and when it happened as it went through. And that's something that you get when you move to using a source control solution based on the Git protocol. Now, GitHub shows us this, but whether you're using GitHub or GitLab or any of those other services we talked about, all of them are going to give us this type of capability that's there, right? So it shows us these types of pieces that are in place. Make sense?
Yeah, I can see why lawyers would like this. I mean, I do a lot of writing as well. And I mean, you can see the advantages of this where you have people collaborating on documents and, just the advantage of keeping track of what's going on.
Absolutely, as they go through. So the commits give us those ability. And then the other one that I wanted to talk a bit about was kind of issues and pull requests. And you know what? Let's do this. I'm looking at the clock and realizing that we've gone on a bit here. So let's actually pick up. I'm going to make a plan here live on the video. So we're gonna talk a bit more about some of the features that the services give us and the pieces. And then in the next video, when we jump back, and I think we'll be meeting next week, is we'll talk more about the actual Git tool, right? How to use it, how to leverage it a bit more, how to contribute back and take advantage of these pieces, rather than try to squeeze that in like 5 minutes here at the end of the video. So, all right. So let's take a look here. So I'm gonna go and grab. I'm gonna see if I can find one that has some good examples that are there. So if I do. Issues. I think we've got up on Cisco DevNet. Yeah, we do. So we have a public repository called DevNet Express DNA Issues. And so what this repository is used for is for anybody that has some feedback. They've maybe gone through one of our learning labs in the DevNet Express for DNA and they found a problem with it, or they found they have a suggestion on how to make the lab better. We've got this repository specifically where people can file what's called an issue. And an issue within a repository system like this is really just kind of what it sounds like. Hey, I found an issue. I think somebody should fix this. And so this issues can be opened on public repositories by anybody. And so that's one of the values of posting open source projects inside of a solution like GitHub, is that if you find a problem with it, you can go ahead and you can open an issue. And so we can take a look at some of these. So it looks like there's a typo in a question that was here. And so if I click at this issue, I can see who opened it. So I can see that T Nothnag, I don't actually know who that is, but somebody opened this up and said, hey, on this area, you got a question. Can you identify which module? get rid of that notification, was used to configure NTP. We can see that there's you can communicate back and forth. So Ann Gentle runs the DevNet technical documentation and writing team that's out there. She manages a lot of these pieces. And so she actually commented back, and it looks like she says, okay, she merged and published a fix. Now, in this case, when she fixed this, she should have closed the issue. So this issue has actually been resolved based on what I can read here, but the issue was left open. And so as I happen to be an administrator on this repository, so I can actually go in here and do some maintenance while we're on the call. So I can say closing issue as the merge was published. So I'm just making a note and saying, okay, I'm going to close this issue, and I'm going to say close and comment this. And so now that issue has been closed. We can see that it's been marked that H. Preston closed it, and then the actual issue itself has been marked as closed up here. And so it tracks all of the history that's there. So I can go back in and I can look at other issues that are out there, and I could go ahead and do it. And so this is one of the things that kind of project maintainers do on code repositories, is that they keep track of the issues. Somebody goes in, they communicate, they gather info, they potentially make the changes that are there. One of the other things that's kind of interesting is the ability to label issues that are there. So I'm going to take a look at this one because it's got some labels on it. So if I look at this one here, we can see that Ruth's one of our project managers in DevNet. She does a lot of the organization for the DevNet Expresses. And so I'm not even going to pay attention to what the content is here, but she opened up an issue that went through. We see one of our other folks in DevNet made a note that was on here. And we can see there's some labels attached. And labels are a way to go into an issue inside of GitHub or any of these tools and say, you know what, I'm going to mark this as a high priority. So you can see priority 1. I can mark it that it's currently in progress. We can see that Austin Marcos has been assigned to this issue that was up here. And so there's a way to kind of say who has ownership of this, where it goes in. If you organize projects as part of your piece that goes through, so you can think about a project saying, hey, we've got a project for this big release. You can attach issues to particular release and milestones, right? To say when these are going to go ahead and get fixed, and all those go through as they go in. And so doing all that is pretty simple. So I'm not gonna actually create one, but we'll kind of dummy up an issue here. So I can say sample issue, and I can go in here and say, okay, this is a sample. No thanks. All right, so I put in the text that's there, and then I can say assignees. So let's say I wanted to assign myself to this. I'm gonna open the issue, and I know that it's an issue. I also know that I'm gonna go fix it. I can go ahead and assign it. I can go ahead and I can label. So there's some built-in labels that GitHub gives you. You can create your own. So I could say, you know what? Let's say that this is an enhancement request, and we'll say that it's a priority 2, and I'll say that it's in progress. So I check the different labels I want to give it, and go ahead and say, okay, we've added those labels, so now we can see that they've been attached. If I don't know if we've got any milestones set up. Yeah, there's no milestones that are set up. But if we had milestones or projects, these could be attached. And then I could go ahead and submit it as a new issue. And then these would be logged as they go in. And so issues give us a way to kind of keep track of all the bits that are out there. Does that make sense? Questions on issues?
That's great, Hank. It's just, I'm really glad that you're showing this like a real example. It's not just fake data. This is actually real stuff. So thanks for sharing that.
Yeah, with luck, I'm not going to stumble into something that I don't want to show up on the video. So.
Yeah.
All right. So we'll go ahead and, like I said, I'm not going to create that issue because it's not an actual one. So let's talk. The next thing I want to talk about are what are called pull requests, which is kind of the other big thing that you run into inside of GitHub as they go in. And I'm going to see if I can find a decent example that might have, I know a project that probably has a pull request. So let's see if he's got any in there. He does. Okay. So the WebEx Teams SDK. So WebEx Teams SDK is a Python software development kit. That's what SDK stands for. That allows you to write code really easy in Python and work with WebEx Teams, which is our Cisco's collaboration and chat platform. We can see that on here, we've got some issues that have been opened and they've been actually gone through and added. So this is actually, I should have gone here at the start because these will be more reasonable and active. So we can see one was opened in there. Now let's say that there was an issue that was opened, and then you, as somebody that went through, said, I know how to fix this issue. What you can do on a repository, so this version of the repository, it's a public repo, but it's owned by Cisco DevNet. And let's say you wanted to make a change to it to fix this issue, but you didn't have, you're not a member of Cisco DevNet. You can do what's called forking. And so over here, there's this button called fork. And so if I fork this repository, and I've actually already done it, but it's been renamed. So when you fork a repository, you make your own version of the repository. So you get a copy of yourself. And so this repository started out, it used to be called Cisco Spark API, and then Cisco renamed the Spark application to WebEx Teams. So the repo was renamed. So I already had a fork that was there. And so now what I've got is my version of this repository is here. The name's a bit different, but we just talked about that. And so on here, I've got full control of this version of the repository. It's the same code. When you fork a repository, you get a cloned copy of that repository in your own account on GitHub. And so now that it's your version of it, you can make whatever changes to your version of the code that you want. And so let's say I made a copy of the code, and then I fixed the bug that was there. And I wanted to have, I want to suggest that the people that own the actual repository take advantage of my fixes. What you do is you open a pull request. And a pull request says, I request this other organization or this other owner pull, basically grab my changes and put them into their version of the repository. And so we can look at a pull request here that's been opened. And so there was one that was opened 3 days ago. The ability to retrieve API tokens for guest issuers. So this user here, this SQU4RKS user, they forked the repository, they made some changes, and now they're asking Chris, CMLCCIE down here, he's the guy who manages this repository, he's saying, hey, I'm asking you to make these, to pull these back in. Now inside of the pull request, you can see there's some automatic builds, some CI/CD stuff that are failing. So obviously this isn't something that we would grab immediately. But as part of the pull request, I can actually see all the changes that were there. And so I can look at the commits. And so if I pull in this guy's changes, there's going to be 3 different commits that were submitted. I can actually I can look at all the files that were changed. So if I was Chris and I was monitoring this pull request and trying to decide what to do with it, I can actually come in here and say, okay, well, under the setup.py file, he's adding a new requirement, this pyjwt token. And then underneath the tests file, he's made some adjustments to the test file here to go ahead and say we're going to update the tests a bit. Looks like it's more a formatting issue than anything. And then down here underneath the init file, he's adding a new pieces. So every change that he's proposing to make is all documented very effectively inside of the pull request as part of that commit process. And so as an owner of this repository, I can review these changes. If I said, this looks good, but we want to make some changes, I can go back and forth and converse with him, and we can kind of talk about what it would be to potentially merge or pull these changes into the main repository. And then if I was happy with it, I could come down here and merge the request in and then take those changes in. This process of somebody having a repository you're interested in, an open source repository you're interested in, forking it to your own copy, updating it, and then asking for pull requests, that's how open source projects work up on GitHub. It's this back and forth collaboration. And so when you have a project like this WebEx Teams SDK that is open source, and you want lots of people to contribute to it, you don't have to give everybody write access to your actual version of it. The way that the process works is people can make their own copies of it, work on it independently, and then they can suggest updates to your own piece that goes through. In fact, that's how Ansible works. If we go over, I know Ansible is a hugely popular project, right? So if I go and I look at Ansible up on GitHub, we can see here there's been, there's over 4,000 contributors. Red Hat, the people that own Ansible currently, right? They didn't add 4,000 people to this main repository for Ansible. No, anybody goes ahead and forks. We can see there's been 14,000 forks of Ansible, and then there have been lots of issues logged and then pull requests that go through. And so every time Ansible does a release, as part of that release, they're merging in pull requests from different contributors that go through. And so if you've got a suggestion to Ansible, you can fork it yourself, you can make those suggestions, and you can send pull requests. And as long as you abide by the Ansible guides, you've got a potential to become number 4,250 contributor if they were to pull in one of your changes. Because anytime somebody's pull request is accepted, you automatically become a contributor on that project. All right, I went on for a bit there, but we went through a bunch of stuff. Let's make sure it was all clear. David, questions?
That's brilliant, Hank. I mean, it's so nice to see it actually, you getting to the end now and showing it with Ansible. I had one question, is this upstream, downstream code thing that people talk about?
Upstream, down. I'm trying to think through it.
Like I'm sending it upstream, like code or something.
Yeah, so that's kind of how these go through. So this when you work with, let me see if there's a good example here. So when you work with a project, you end up with different forks and branches as things go through. And so normally when you talk about sending upstream, is you're taking something from a fork or a branch, and we'll talk more about branching in the next call. And you say, okay, I want to send this back up the tree of all of these branches and these forks to the main root of the project. So example for Ansible here is if you're sending upstream, you're trying to get it from your own location so that Ansible has it and it gets considered as part of the work that they're going to release that's out there. Downstream is often going to be something like that isn't part of the main branches or the main releases of a code. It might be off someplace on an experimental branch or an experimental spot. Once it's been tested and validated, getting it kind of upstreamed up is going to kind of get to the original source of that project so other people can take advantage of it. Make sense?
That's brilliant, Hank. I know we're out of time, so unless you've got something else to say, I just wanted to say thanks very much again for sharing your knowledge.
Yeah, I've always got more to say, but I think we've probably got enough for today's session, and we'll pick up more. But what we'll do in our next one is we'll kind of dive deeper in, and we'll start working with the tools, make our and see how we can do commits and make changes to files, and kind of pull away some of the mystery around using Git for network engineers. So.
Brilliant. Thanks so much, Hank. All the best. Have a great weekend.
You too, David. Talk to you soon.